Hello children, we are starting with the new topic, mensuration. Let us recall what we have studied earlier. Three-dimensional figures is such that this is known as x-axis, this is known as y-axis, and third one is known as z-axis. So this is known as three-dimensional figure, cuboid. Here you see this is x-axis is known as length, y-axis is known as height, and z-axis is known as breadth. You might have seen the 3D movies. In that, three-dimensional film is there. The z-axis is there. It is towards the camera. So whenever any object is shown towards the camera, the audience feel in the movie that it is coming towards them. So that's why it is known as 3D movies. So your three-dimensional figure. All three-dimensional figures have volume. Two-dimensional figures, we don't consider the volume. So in this cuboid, we are going to see the lateral surface area and volume and total surface area. Lateral surface area means vertical faces. This is length into height. How many faces are there? This side and this side. Breadth into height. How many faces are there? This side and this side. So twice length into height and twice breadth into height, twice height taken common. So lateral surface area will be 2h into L plus B as shown on the screen. This is lateral, again I repeat, we can call it as vertical surface area like this. Got it clear? All four sides vertical. Next comes total surface area. In the vertical surface area, we will add the area of the top as well as bottom. What will be the area of the bottom and top? Length into breadth. 1. Length into breadth. 2. So total surface area of this cuboid will be twice length into breadth plus twice breadth into height plus twice height into length. So all the six-sided area will be added. Now volume. As I said earlier, three-dimensional figure has volume also. So here the volume of cuboid will calculate as length into breadth into height. So volume of cuboid will be length into breadth into height. Next three-dimensional object is cube, whose length, breadth and height are equal. So lateral surface area or vertical surface area of this will be what? All length, breadth and height equals to L only because they are same. All sides are equal. So 1L square, 2L square, 3L square this side and fourth one towards my side. So vertical surface area or lateral surface area what is given will be 4L square. Very easy. Total surface area of cube will be 6 sides. 1, 2, 3, 4, 5 and 6. So 6L square will be total surface area. Then volume. Length into breadth into height, but all are same, L. So it will be L cube. Next object is cylinder. Now here you see, this is the rectangular sheet. If I want to fold it, so length and breadth of the rectangular sheet is here. So if I fold this length like this, it will form a cylinder. Do you agree? A cylinder will be formed. So length is converted into circumference of the cylinder, circle, this circumference. And the breadth is converted into height of the cylinder. Understood? Length will be converted into circumference, that is 2 pi r of the cylinder, circular region, and breadth will be converted into height. Now, if I turn this page here like this, rectangular sheet, this is breadth, this is length. If I fold this in a circular way, what will happen? The breadth will be converted into the circular region and length will be converted into height. So breadth will be 2 pi r and h will be its length. This is the cylinder. Got it clear? So this circular region will be 2 pi r, height will be this. Curved surface area of this cylinder will be 2 pi rh. What is 2 pi r? The circumference. 2 pi r will be the circumference into height. We have seen the two examples there, how it comes. So 2 pi r into h will be the curved surface area. Total surface area will be, now here you see 2 pi r h plus pi r square on the top circular region, pi r square at the bottom also circular region. This will be closed. Cylinder will be closed from both the sides. Pi r square on the top and bottom also pi r square. So it will be 2 pi r square. So total surface area will be 2 pi RH, that is curved surface area, and 2 pi r square top and bottom. So 2 pi r we will take common. Total surface area will be 2 pi r in bracket r plus h. Now volume. What is the area of the base here? Pi r square into height. Pi r square into h. So that will be the volume of this cylinder. Next is cone. Cone, you know, ice cream cone is there. Birthday cap is like a cone. So here, this line is known as a slant height. This height, perpendicular, this height is known as the height of the cone. This is known as the slant height. And radius of this circular region will be r. Radius of this circular region will be r. So slant height, in the diagram you can see on the screen, slant height square L square equals to h square plus r square by applying Pythagoras theorem, because h and r make an angle of 90 degree as shown in the figure on the screen. So, or L equals to root of h square plus r square. Now curved surface area, this curved surface area is taken as pi r L. total surface area. Curved surface area is pi r L plus pi r square, area of the bottom. This cone is at the bottom. So total surface area will be pi r L plus pi r square base here, circular region. Taking pi r common, it will be r plus L. Volume of this cone equals to 1/3 of pi r square h. Now pi r square h was the volume of what? Cylinder. So if I take this cone like this, fill any sand I suppose, and take the same height and same radius cylinder and pour the sand filled with this into that cylinder, the three such cones quantity of sand will fill completely in the cylinder of the same height and same radius. You can do it practically if you want to try it. So volume of this cone will be 1/3 of pi r square h. Next object is sphere. Sphere, you know, ball. It is round in shape. So surface area of sphere is 4 pi r square. And volume of this is 4 by 3 pi r cube. If I make this sphere half, as shown in the diagram, it will be hemisphere. Suppose this is half. This is not half actually. Suppose this is half. So curved surface area will be half of the surface area, that will be equal to 1 by 2, 4 pi r square. It will be half pi r square. And total surface area of hemisphere will be curved surface area of hemisphere, that is 2 pi r square plus pi r square at the bottom, this part. So it will be total surface area equals to 3 pi r square, and volume will also be half of volume of the sphere, that will be equal to, as shown in the diagram, half of 4 by 3 pi r cube equals to 2 by 3 pi r cube. Next one activity is given on the next page in your textbook. I'm sure you can see on the screen here. Now this circular ball is there R with radius R. This is a cylinder kept here. On one page a strip is taken. Diameter of this sphere, that height is taken here, and it is divided into 3 equal parts as tick mark here. This is one part, this is another part, and this is the third part up to here. So 2r is the height marked here. Liquid is filled and this sphere is inserted in this. The radius equal to this cylinder. So it will fit like this. When you put it, this is 1/3 filled. So the sphere will be inserted in this and height will be equal to the diameter of this sphere, that is 2r. Therefore, the volume of the part of the beaker up to height 2r can be obtained by the formula of volume of a cylinder. Let us assume the volume is V. V equals to pi r square h equals to pi r square into 2r equals to 2 pi r cube, since h equals to 2r. Height of this cylinder up to here is 2r. So h equals to 2r. But volume of ball plus volume of water, which was already in the beaker, this figure. Volume of the ball plus 1/3 of into 2 pi r cube. Why 1/3? 2 pi r cube is the volume of the cylinder. 1/3 because it was filled 1/3 only. And volume of the ball is the volume of this circular. So this total comes. So volume of the ball equals to, take this V, this is V, total volume of this figure. Volume of the ball equals to volume of this figure minus volume of this figure. That is, this figure volume is 1/3 into 2 pi r cube. And volume of this figure is V. So volume of the ball will be V minus 1/3 2 pi r cube. Simplify this. V equals to 2 pi r cube minus 2/3 pi r cube. Simplify this, equals to 6 pi r cube minus 2 pi r cube upon 3 equals to 4 pi r cube upon 3. Hence, we get the formula of the volume of sphere equals as V equals to 4/3 pi r cube. Very clear? In the next video, we will turn to practice set 7.1. Till then, goodbye. Take care of yourself. Thank you.